Chapter 4, chemical quantities and aqueous reactions. Another little section related to the atmosphere. So our Earth is surrounded by a layer of greenhouse gases, and these allow sunlight to enter our atmosphere and warm the Earth's surface, and then they act almost like the ceiling of a greenhouse and prevent a lot of that heat from leaving. So this is a very, very good thing because we need the temperature to be warm enough that we can grow food, right? So there's a very important balance between incoming energy and outgoing energy. We need the average temperature of the Earth to be pretty constant. Of course, you're probably all familiar with the controversy about global warming and holes in the ozone and that we're making too much carbon dioxide. It's very interesting, this book by Bill Bryson that I've been listening to. He talks about ice ages and how the Earth has gone through many ice ages, and what's really disturbing is that we're not sure what precipitates an ice age. Very, very interesting. And I think what most people do not realize is how little we really know about all of this. I mean, we definitely need to be concerned about what effect we are having on the environment. It is very much up for debate how significant our impact is, whether it's really going to affect anything or not. And so, yes, be environmentally conscious, but don't freak out. I think for a lot of things, sort of a moderation approach is good. So scientists have measured an average 0.7 degree Celsius rise in atmospheric temperature since 1860. Okay, if you look at the entire history of the Earth, the time period since 1860 is just a blip, right? Very, very short period of time. But yeah, they measured this, okay? And so over here on the right, we see a graph of global temperature, and this looks all very disturbing in this big, big change. Well, but here the difference is these are measured in tenths of a degree Celsius, right? So we're talking about really small change. And look at the annual change. I mean, the temperature goes up and down. We have cold years and warm years, but we have seen this increase. Is it statistically significant? It depends on who you talk to. The thing about numbers is you can manipulate them to say almost anything you want. And so that's why there's so much controversy. So we can also look at an increase in atmospheric carbon dioxide from 1860, that this has also increased. It's risen 38%. But then what we have to ask ourselves, are these two trends causal? Not casual, but causal. Is one of these causing the other? It's one thing to observe the trend. It's another thing to understand why it's doing that and what it means. These are just some things to think about. We're going to use this as an introduction to look at this combustion reaction that produces carbon dioxide and get into stoichiometry. So one of the sources of carbon dioxide is combustion reactions from fossil fuels. Okay, so most of us probably contributed to carbon dioxide as we were coming here. Unless you rode a bike, walked, or drove a purely electric car, which you could still argue that that's generating CO2 because where did your electricity come from? But here's an example of combustion reaction. So here we have a hydrocarbon. It combines with oxygen, forms carbon dioxide and water. So that's a source of carbon dioxide, but there are also natural sources of carbon dioxide. Volcanic action. Volcano goes off. That puts a lot of carbon dioxide into the air. Even volcanoes just kind of burping a little bit here and there causes carbon dioxide. So how can we tell if this global warming is natural? I mean, if we weren't doing anything, it might still be going up just because of volcanoes. How do we tell? That's a hard question. Well, you can kind of get an idea. Oh, this is a new section. I better start a new one.